So next topic is replacement policy. For replacement policy, it is about a policy to decide which or when is the best time to replace an asset. Okay. In the company, okay, for example, if you have a machine or assembly line, your boss may ask the finance department or, for example, your finance manager to explain to him, okay, when is the best time to replace the whole assembly line or the machine, given it can contribute the lowest negative NPV to the company. And the first task is about to establish what the policy are. Okay, for example, if the maximum life of a machine is 4 years lifetime, there are 4 replacement policies. You can replace every year, every 2 years, every 3 years, or every 4 years. So you have to set the policy first. And the assumptions to make the evaluation is, whichever replacement period chosen, it will be consistently used. What does it mean? It means, for example, if you chose 2 years policy, then every 2 years the machines will be replaced. Okay, you cannot change, for example, after 2 years or you change 3 years. Okay, no. Under the evaluation method, we assume that if you chose 2 years policy, then you have followed the rules, follow the policy on comparison. Okay, just the example we showed before. For example, you have machine with 4-year life. Okay, machine with 4-year life, and you have 1-year policy, you have 2-year policy, you have 3-year and 4-year. Okay, so how to compare or how to make the evaluation? Okay, for this 4 different policies, you have to find the policy in 12 years. Okay, because 12 years is the common factor for all these 4 policies. Okay, if, for example, it is only 3 years, so the common factor is 6 years. Okay, just an example. You have to evaluate for 6 years on 1-year policy, so you have to replace maybe many times, and 2-year policies under 6 years, how many times that you have to replace the machine. So next is no new methods of machine become available with different cost characteristics. Okay. There's no technical innovation, which is totally unrealistic. Okay, under this replacement policy or asset replacement topic by ACCA, okay, assumptions. The second assumption is quite different. Okay, for example, under right now, the technology, I don't say about 1 year or 2 years, or maybe within within a year, that even the technology can be advanced much more in another level instead of staying in the 6 months before. So no new models of machine become available with different cost characteristics. I think it is not realistic under the technical innovation era. But okay, just the assumption, so just remember it. We don't assume any inflation here. Okay. The cost of capital and costs are given in real terms. So here we assume all are in real terms. To handle inflation with money cash flow in this type of example is much more complex. Okay, we remember here we don't assume any inflation. So no inflation shouldn't be in replacement policy consideration. Okay, we assume no inflation because it is very difficult or challenging for an FLI student to handle inflation in replacement policy. There's no new models of machines become available, okay, and also the policy is consistently used. We have two methods to share. First method, okay, is the traditional method, or very how to say that, a conservative method, or traditional method. Establish the lowest common multiple of years of various policies. Compute the NPV for each policy over this number of years. Okay, so what does it mean? So it means you have to compute the NPV of each policy, then to compare which one gives you the lowest common give you the lowest NPV, because it's negative NPV. So give the lowest negative NPV to you for the policy, then you chose it. Next is examine the NPV of one complete cycle from purchase to sale for each replacement policy divided by the appropriate annuity factor to get the equivalent annual amounts. Okay. The second method is much easier and leads to the same direct decision. So it is suggested to use the second method instead of the first method. Okay. So the first method is only for illustration. So here is the illustration, an example. So please read it and then just come back. I will share with you how to work it out. Okay, good. Come back. So we showed you for these questions. It's a question asking you about a replacement policy. You have machines with 4-year life. Okay, the cost is 45,100. No inflation, maintain the same. Other relevant costs and trade-in values are shown as below. So there's no inflation. So you can imagine here the cost of machine. Okay, under each scenario is the same for every policy. So please work it on how to work out then the equivalent annual cost model to find which policy should be adopted. Okay. So and here I showed you two table. The first is the net present value table, and the other is annuity table. Okay. So the policy year, we write it down here. The policy here, we have 1, 2, 3, 4. Okay, and for each policy year, you have different cash outflow pattern. For example, if you choose 1-year policy in the year 0, okay, the cash outflow is 45,800, and then in the first year, after first year, you sell the machine, right? You sell the machine, and what's the sales value, or the money that you can get after the first year? You can get 29,200, right? But you have to pay the operating expenses and also the maintenance cost. So altogether is 24,800. Okay. We assume all expenses are paid at the last of the first year. Okay. It is also an unrealistic assumptions, but we made this assumption because we like to make the life easy for us. Okay. So the net is 4,400. Okay. Then that's it. It's the policy. The cash flow in the beginning of the year or the initial time, and also after first year time, you get 44. And you have to invest. After first year, you have to invest 45,800 again. And second, in the 2-year policy, same. In the year 0, it's the same. Okay. And for the first year, you don't sell it, you don't sell the machine. Okay. But you have to pay the first year operating cost and maintenance cost. So it is minus to 24,800, and then you sell a second year. In return, you have to pay the operating cost and maintenance cost as well. So the net is 8,100. It's the net. Okay. After after taking out the operating cost and maintenance, and then even you get the residual value, or you can get the money back by selling your machines, but you have still net cash outflow 8,100. So in the 3-year policy, follow the same logic. Follow the same logic as 2-year policy. Okay, in the second year, you have to pay the operating cost and the maintenance cost. So by the end of third year, you sell it. Also, you have to pay the cost. So in the 4-year policy, okay, follow the same rule. Okay, follow the same rule. Then you have this policy in each policy year on the cash flow. It's the cash flow for each year before discounting. So you have to find out by discounting those cash flow into net present value, So you have to adopt this discount factor at 10%. Okay, at 10% to make the discount on this cash flow. So next page. And after making the discount, so there's 4 policy. Okay, under the discount factor on year 0, okay, is 1, and then is hold on, okay. Just refer this table because I just put it here. Okay, for the first year, you have 2 cash flow, and the second year you have 45,800, and then 25,564, and then 6,694. For 3-year policy, for the same. The difference is in the 3rd year and the 2nd year and the 3rd year. So we make it Okay, for 4-year, same. Okay, so you have this from year 0 to year 4. Then you find out the NPV. For the 1-year policy is 41,800, and for the 2-year policy is 75,040. Okay, it's all negative numbers. Okay, I'll show you all. Okay, I'll show you all here. Then the key point is, because don't forget, these numbers are coming from different policy, the different policy year. So you have to adopt different annuity factor. Okay, to make the comparison, because we need to make the comparison which contribute the least negative NPV. So we have to divide the numbers by the annuity factor. If you check your formula sheet, in your formula sheet, you find different annuity factor in different years. Okay, so I just put them down here. It's annuity factor. Yep. Okay, so you can get the final result. Okay, the final result for the 1-year policy, the equivalent annual cost. Okay, the EAC, equivalent annual cost. First, for the policy year, it's only 1 year, it's 45,800. For 2-year policy, it's 43,226. And for 3 year, it's 43,918. For 4-year policy, it is 44,323. So it means the best or the lowest negative NPV policy year should be 2-year policy. So we go for 2-year policy, or we suggest 2-year policy to the management. Okay.